Welcome to the DIY Honda Garage channel. The DTC P2183 refers to an issue with the Engine Coolant Temperature ECT Sensor 2 circuit, indicating a range or performance problem. This error is part of the Honda Powertrain Control Module (PCM) diagnostics. The ECT sensor plays a pivotal role in monitoring the coolant temperature to ensure optimal engine performance and fuel efficiency. It is situated near the engine block, usually on the thermostat housing or close to the engine's coolant outlet. When the ECT sensor encounters problems, it can lead to inaccurate temperature readings, which may eventually affect the vehicle's performance, emissions, and fuel consumption. In this guide, we will thoroughly troubleshoot DTC P2183 with detailed steps to find the root cause of the issue and apply the necessary rectifications. The ECT Sensor 2 is responsible for measuring the temperature of the engine coolant, which directly influences fuel injection and ignition timing. This sensor sends voltage signals to the PCM, thus constantly updating the engine management system concerning the temperature of the coolant. Correct readings from ECT Sensor 2 are essential for the proper adjustment of air-fuel mixtures and maintaining overall engine performance. The typical location for ECT Sensor 2 is mounted on or near the engine block, usually integrated with the thermostat housing. Any abnormalities in this sensor's performance can lead to severe operational issues, including poor fuel economy and increased emissions. Recognizing the importance of this component is crucial for effective diagnosis and resolution of the P2183 error code. There are several potential causes leading to the DTC P2183. One common issue is poor or loose electrical connections at the ECT Sensor 2. When the connectors are compromised, it can lead to erroneous signals being sent to the PCM. Additionally, if the ECT sensor itself has malfunctioned or is faulty, it can significantly affect its ability to provide accurate temperature readings, triggering the DTC. Another contributing factor may involve the Powertrain Control Module (PCM), as software glitches or failures may result in erroneous interpretations of sensor data. It is vital to investigate these concerns methodically to provide appropriate solutions to the identified problems. When a DTC P2183 is set, several symptoms may be observed while operating the vehicle. The most apparent indication is the illumination of the check engine light on the dashboard, alerting the driver to a potential issue within the engine management system. Additionally, drivers may notice degraded engine performance, manifesting as rough idling, stalling, or hesitation during acceleration. Furthermore, an unreliable ECT sensor can lead to poor fuel economy, making the vehicle consume more fuel than necessary. Recognizing these symptoms early can prevent further complications and potentially costly repairs down the line. The first troubleshooting step involves performing a visual inspection of the connectors associated with ECT Sensor 1 and ECT Sensor 2. Here, it is critical to check for poor connections or loose terminals that may compromise the ability of the sensors to send accurate readings to the PCM. A quick examination can often reveal signs of corrosion, wear, or disconnection affecting the sensors. If the connections and terminals are found to be in good condition, you can proceed to the next step. This inspection is pivotal as many electrical issues originate from simple connection problems which can be easily overlooked. In the second troubleshooting step, begin by turning the ignition to the on/I position without starting the engine. Use the Honda Diagnostic System (HDS) to check for any pending or confirmed diagnostic trouble codes. By doing this, you can determine if the P2183 code still exists, or if any other related codes are being reported. such as DTC P2183. If both DTCs are indicated simultaneously, it is essential to follow a specific troubleshooting sequence, starting with DTC P2183. On the other hand, if only the P2183 code is present, you will proceed to the performance checks for ECT Sensor 2. This step is critical to establish the current status of the onboard diagnostics for targeted troubleshooting. During the third step in troubleshooting, start the engine and allow it to idle for approximately 10 minutes to ensure it reaches operating temperature. Using the HDS, observe the readings from ECT Sensor 2. Specific attention should be given to whether the current operational conditions of the ECT Sensor 2, measured in degrees Fahrenheit or Celsius, are below the threshold of 120 Fahrenheit or 49 Celsius. If the readings match the expected performance standards, the next step includes replacing ECT Sensor 2 and verifying the repair. If the readings do not align with the thresholds, proceed to the next step for further diagnostics. In this fourth step, safely turn the ignition switch to the lock, 0 position, and allow ECT Sensor 2 to cool down to ambient temperature. Once cooled, note the ambient temperature for comparative purposes. After this, turn the ignition back to the on, 2 position again, and quickly check the reading from ECT Sensor 2 via the HDS data list. This check serves to validate that the sensor's reading should be in close proximity to the ambient temperature. If the value of ECT Sensor 2 significantly diverges by 5.4 degrees Fahrenheit or 3 degrees Celsius or more from the ambient temperature, it indicates a malfunction of the sensor. Replace ECT Sensor 2 if it does not align. Otherwise, check for intermittent failures and connection issues. In the fifth step, start the engine once more and let it idle for about 10 minutes again. Use the HDS to inspect the current operational parameters from ECT Sensor 1. You will want to ensure that this sensor's readings are also below the critical threshold of 120 degrees Fahrenheit or 49 degrees Celsius. If ECT Sensor 1 is performing as expected, it should likewise match the required values. Should the readings confirm proper performance, you can proceed to the sixth troubleshooting step. Conversely, if ECT Sensor 1's data does not align with the outlined threshold, replace the sensor and confirm the resolution of the DTC P2183 by following the necessary repair verification procedures. While repeating the idling of the engine for 10 minutes in the sixth step, check ECT Sensor 2 once again with the HDS to verify its performance. Reviewing the sensor's readings, ensure it appears below the 120 degrees Fahrenheit or 49 degrees Celsius threshold. If the sensor is operationally sound and confirms these readings, it indicates that the issue may not lie with ECT Sensor 2, and you would be required to proceed to the next step. However, if the readings are within the expected range, you will need to consider replacing ECT Sensor 2 and also remember to carry out the repair verification after any alterations to ensure accuracy in the repairs performed. In the final step of troubleshooting, turn the ignition to the lock 0 position again and allow both ECT sensors to cool down to the ambient temperature. After they have cooled, note the ambient temperature one more time. Turn the ignition back on to the on 2 position and quickly check the readings for ECT sensors 1 and 2 through the HDS. Compare each sensor's readings to the ambient temperature to see if either differs by more than 5.4 degrees Fahrenheit or 3 degrees Celsius. If either reading deviates outside this range, replace that particular sensor. If both sensors are functioning correctly in this regard, further diagnostics may be necessary to address potential intermittent failures in connections. The final repair verification involves some crucial steps to ensure that any previous faults have been rectified appropriately. First, turn the ignition switch to the on-to position. Next, utilize the HDS to reset the Powertrain Control Module (PCM), which is essential in clearing any diagnostic trouble codes that might still be stored. After resetting, execute the PCM idle learn procedure. This allows the PCM to relearn idle settings and adapt to the vehicle's updated conditions, ensuring optimal performance. Finally, use the HDS again to check for pending or confirmed DTCs to affirm that DTC P2183 has been resolved. If the error code reappears, further investigation is required to determine any underlying issues. Preventive maintenance is crucial to ensuring the longevity and reliability of the ECT sensors and the overall engine management system. Regular inspections of sensor connections and electrical terminals can help avoid future complications related to loose or corroded connections. Periodically checking the performance of ECT sensors and ensuring they operate within the defined parameters contributes to maintaining ideal engine performance. Additionally, it is essential to monitor coolant levels consistently to prevent overheating and ensure that sensors can read properly. Following these recommendations will help reduce the likelihood of error codes like P2183 appearing in the future, thereby supporting the vehicle's efficiency and reliability. In summary, comprehending the function of the engine coolant temperature (ECT) sensor is critical to diagnosing and resolving DTC P2183 effectively. By systematically following the detailed troubleshooting steps outlined in this guide, one can ensure that each potential point of failure is examined thoroughly. Key steps include visual inspections, performance checks, and final verification processes. Additionally, incorporating regular maintenance checks can proactively prevent similar issues from arising in the future. Taking all these steps ensures that your Honda CRV operates efficiently and reliably, saving you time and expense in the long run. Please like and subscribe to the channel. See you next time.